Okay, welcome class. We've been talking about the costs of the company. And in particular, we've been mentioning that in a lot of decisions, rather than use the classifications used in financial accounting and balance sheets and income statements, sometimes it's more useful to be able to present them as variable versus fixed costs. And that's what we're going to continue to look at today. We will also be solving some questions towards the end of the class. But first, I want to point out what sort of an effect it has depending on the proportion of fixed versus variable costs. This is typically referred to as operating leverage. You may have heard of leverage as financial leverage before. That was looking at how much of your financing comes from debt versus equity financing. And we differentiate these because debt financing has a fixed payment that has to be made on it. We typically call this interest. But once that is satisfied, any additional profits remaining go to the investors, the equity holders in the company. So using borrowed money allows the investors to become owners of larger companies. And as long as that borrowed money is used efficiently in a manner to earn higher rates than the interest that is paid out, this will end up magnifying the returns to the equity holders. However, there is risk involved in this. When times are bad, when the economy isn't doing well, and when profit sales are low, having high level of financial leverage, as we saw earlier, can lead to pretty significant losses in profitability. So that is the downside. And companies that don't have any borrowing, any debt, can't go bankrupt until they lose all of their assets. However, companies that borrow money can be forced into bankruptcy anytime they don't have enough cash on hand to make the payments on the debt. So sometimes you can get into trouble even if you have enough assets to meet the debt, if you don't have the cash on hand to make the payments. When you have to liquidate assets in a hurry, you may have to sell them at significantly below their market values. That's another problem with having non-liquid assets. But today's subject is about the cost structure. And so it's not about financial leverage, it is about operating leverage, okay? So here, cost structure refers to the proportion of fixed and variable costs in an organization. And managers sometimes make choices which affect their organization's cost structure. For example, a manager that is deciding on the size of a facility, of a factory. They may choose to go with a small-sized factory, in which case the fixed costs will be relatively low, but variable costs will probably be higher. If they had gone with a large factory size, building a huge building, buying expensive equipment and stuff like this, then the fixed costs, the rent, the depreciation, and so on, would have been high. But the variable costs in that type of the large factories tend to be much lower. So these kind of choices, what effects do they end up having on the company? Well, they affect the degree of operating leverage of these organizations. So there are advantages and disadvantages to having, one structure versus another, and typically they are going to be opposed. So when you have high fixed costs, okay, which also implies low variable costs, in that case, you get the benefit when things are going well, when sales are rising rapidly, then you are able to divide that fixed cost across a lot of production. And as a result, you probably can end up increasing your profitability quite rapidly. However, If your company is faced with a lot of variability, so sometimes you will have downturns, in that case, high fixed costs could be potentially a time when you lose money and may even, go bankrupt if things go real bad. So in that case, the advantage would actually be to having low fixed costs. And as a result, you're more reliant on, more variable costs. It's like, think of it this way. In my entrepreneurship classes, typically I mentioned that until you're certain that the thing that you're trying to produce is going to be able to sell and is going to be able to sell in large numbers, try to have other people produce it for you rather than buying expensive equipment and setting up a factory. Why? Well, because oftentimes the thing that you think the customer wants isn't really what they want. So until you're certain of this, don't make the big investments, because you may get stuck with very expensive equipment, which you don't need. So initially, even if it's a little more expensive per unit, for the first 1, 2, maybe 10 products, why not have it produced in somebody else's factory? Or even better, with today's technology, you might be able to 3D print some of those things. And you may actually take them to the customer. And if the customer buys and is happy and you get many more orders, maybe then it's the time to go and build that factory, buy that expensive equipment. But until you're certain that it can be done and that the customers want this and they're willing to pay for it, try to keep your fixed costs low so that you don't end up losing all of them. So that's what we have. Advantage of high fixed cost structure, income will be higher in good years. So once you surpass break even, you end up with significantly more profit when you have high fixed cost, low variable costs. But the disadvantage of the high cost structure, yes, is when sales are low. So in bad years, you end up losing more when you're below. Even if your sales are zero, all of the fixed costs still need to be paid. So that's when things are bad. So this operating leverage, how sensitive is your operating income to percentage changes in sales? So how do we measure this? So this measure we call degree of operating leverage, or operating leverage factor, OLF, let's use this, is basically equal to your contribution margin, which is equal to your sales revenue minus your variable costs, divided by your net operating income. So if we put numbers to this, so for our bicycle selling example, we were selling $250,000 worth of bicycles, 500 bicycles at, I guess it was $500 each. The variable expense was $150,000. And as a result, your contribution margin was $100,000. And we had $80,000 fixed expenses, leaving us with a net income of $20,000 when we're able to sell 500 bikes. So at this point, our operating leverage factor is 100,000 contribution margin divided by 20, the net operating income. The difference between net income and net operating income is that after net operating income, if you have debt, you would deduct interest expenses. And if there are taxes, you would deduct tax expenses, giving you net income. So I think this should rather be called net operating income at this point. So operating leverage. If your company has an operating leverage of 5, as we just calculated, if racing company increases its sales by 10%, what's going to happen to net operating income? Well, net operating income is going to increase by 50%. So the percentage increase in sales, you simply multiply that by the operating leverage factor we just calculated, and that gives you the percent increase in profits. Sounds quite high, right? Well, how do we know it's true? Well, let's check the numbers. So here was our actual original state, selling 500 bicycles at a price of 500 each. Then if sales increase 10%, so we have another 25,000 of additional sales. What happens is 275 are our sales. Our variable expenses also go up 15%. They're variable, right? And the contribution margin also goes up 10%, right? So the increase in sales actually is also equal to the percentage increase in contribution margin. The fixed expenses stay constant at 80. So we have net operating income, which becomes 30,000. So notice that from 20,000 originally to 30,000 new net operating income, the increase is 50%. So as we said before, the 10% increase in sales in a company that has an operating leverage factor of 5 yields to a 50% increase in net operating income. So sounds good. One thing to note, the operating leverage factor isn't constant, so be careful. So if we had another 10% increase in the sales, would we expect another 50% increase in the net operating income? Not necessarily, because be careful, now the new operating leverage factor is 110 divided by 30. It is no longer equal to 5. It's actually come down a little bit. So let's look at the coffee selling example that we had from before to try to understand, how can we use this in other places as well. So we had the espresso stand, average selling price 149, variable expense 0.36, average fixed expense per month $1,300. If we were selling 2,100 cups, what is the operating leverage of this company? Well, you could actually go through all the steps and do the calculations, right? So 2,100 cups at 149, 3,196. Then 2,100 times 0.36 is 756 variable cost of this. So 2,373 and so on. So we could do all of those calculations, as I'll show you here. So selling 2,100 cups, sales, variable cost of this, contribution margin, and then the fixed expenses deducted leaves us net operating income of 1,073. So if we wanted to find the operating leverage factor of this company, what do we need to do? Well, we need to take the contribution margin, 2,373, divided by net operating income. And when we do that, we find 2.21, which is A among the alternatives. So the operating leverage factor for this company, Coffee Klatch, would be 2.21. And how do we use this information? Well, next, let's take a look. If sales increase by 20%, by how much should net operating income increase? So 2.21 operating leverage factor. If sales go up 20%, then 20% times 2.21, well, it sounds like D, 44.2, is the appropriate alternative. Yes, so the percentage increase in sales times the operating leverage factor, which we calculate as 2.21, gives us the increase in profit of 44.20%. And if, in order to verify this, let's go through the actual full calculation. That 2,100 cups versus 20% increase to 2,520 cups. Sales goes from 3,129 up to 3,755. So this is that 20% increase. Variable expenses also go up 20%. So contribution margin ends up going up 20%. The fixed expenses stay constant, which means that my net operating income goes from 1,073 up to 1,548. When you calculate the percentage change, it comes out to be 44.2%. So our findings has been supported by the data. Next, yes, the operating leverage factor is your contribution margin by net income. And again, remember that once you calculate it, you can't continue using that forever. After every change, make sure to calculate the new operating leverage factor for your company. And the greater the operating leverage, the greater the sensitivity of its profit to changes in volume. Yes. So if you have a big operating leverage factor, even relatively small changes in the sales level can lead to significant increases in your profits. So that's where we are. Next. So let's look at these two companies. So the operating leverage of the two companies, which have identical sales and identical net income numbers. So the only difference between these two companies is in their fixed versus variable expense percentages. In company A, they have relatively high variable expenses, but relatively lower fixed expenses. In company B, much less variable expense, but significantly more fixed expense. But if you add them up, 450,000, 450,000 total expense in both of the cases, leaving a net income of 50,000. Now, let's consider, if there was an increase or a decrease in sales, what would be happening to the net income of these companies? And to help us out, let's not forget to calculate our operating leverage factors. So the operating leverage factor is equal to the contribution margin. In company A, it is equal to 200,000 divided by 50,000, which is the net income. For company B, the contribution margin is 450,000, significantly higher, as variable costs are quite low for company B, divided by, again, 50,000, which is the net income, which is identical across the two companies. So even though the two companies, their sales and their net income, so starting point and ending point, are the same, the difference is in the variable versus fixed structure of that expense. And here we can obviously see that company B has significantly higher operating leverage. Their fixed expenses, excuse me, let me correct that. Yes, fixed expenses, company A, 150,000, company B, 400,000 out of the total 450,000. So as a result, we can see here that the higher fixed expense structure of company B leads to a very high operating leverage factor of 9 versus an operating leverage of 4 for company A, which is still pretty high, but not anywhere near to company B. So if we increase the sales of these companies from 500,000 to, by 10%, 550,000, what would happen? Well, you can go ahead and do the calculations, but I think that I can safely tell you that if both of their sales went up to 550,000, the net income number for company A would go up by 10% times 4, 40%, whereas the net income for company B would go up by 10% times 9, or 90%. It would almost double. You can check those numbers on your own. So yes, which company will have the greatest change in net income? Company B will have a much bigger increase in its net income when they have the same increase in sales, because it has a much higher operating leverage factor. Its fixed expenses to total expenses make up a bigger chunk. Okay, so if we go back to some of these rules that we have learned, let's try to summarize them so that we can try to use them as well. High variable costs lead to lower contribution margins and less vulnerable in crisis time. So when all of a sudden you find that your sales are falling a lot, it is the fixed costs which can potentially lead to bankruptcy. So if your costs are very low fixed, more variable, when you don't produce and sell, you don't have the expenses. So it's not that bad. High fixed costs cause higher break-even point. Yes, it leads to a higher break-even because break-even point, remember, is equal to fixed cost divided by contribution margin percentage. If you want it in dollars, if you want it in units, contribution margin ratio. So high fixed costs cause higher break-even point. That's correct. However, after the break-even point, the profits increase faster than the high variable cost company. Yes, once you hit the higher break-even point, the profitability starts to increase quite rapidly because they have relatively low variable costs. So their contribution margins tend to be higher in these companies. Degree of operating leverage, the operating leverage factor we've been mentioning, is equal to contribution margin over net income. That's what we were calculating. For a given percentage change in sales, the change in income will increase by the percentage increase in sales multiplied by the operating leverage factor. So in our example, a 10% increase in sales in company B had led to a 90% increase in net income or net operating income. The degree of operating leverage decreases as the sales move away from the break-even point. Yes, so after break-even, and actually right after break-even, because the net income is relatively small, any increases in a small number typically are pretty large percentages. But as you move away from break-even, the profits become bigger and bigger. So the same increase is a smaller percentage. So moving away from the break-even point, the operating leverage tends to slow down, tends to become smaller. And then finally, if variable costs are high, degree of operating leverage is low and vice versa. Yes, operating leverage basically means that if you have high relative within your expenses, if your expenses are dominated by fixed expenses, this means high operating leverage. If your fixed expenses are low, meaning your variable expenses are more dominant, in that case, it is said that you have relatively low operating leverage. And again, if you think the economy and your company is going to do great, then having high operating leverage can be beneficial for you. So set up a big factory, a huge factory. But be careful, because if there's a downturn, if there's a slowdown, that huge factory may cause you to go bankrupt because it has a lot of fixed costs which need to be paid no matter what happens. So let's look at some more examples of how these things we've learned can be used. For example, how do you compensate your salespeople? So your sales commissions can be maybe directly a percentage of the sales number. It could depend on units, but we want to show you an example where not being careful about how you pay sales commissions may actually be harming the company. So in this example, we have two types of products. We have XR7 and Turbo surfboards, which we're trying to sell. XR7 100 is the relatively cheaper version. However, it has a contribution margin per unit of $25. So its variable cost, basically you can tell from this, must be $75. So that leaves us with a contribution margin of 25. So it's pretty cheap to produce relative to the Turbo version, which sells for 150, but has a contribution margin per unit of only $18. So yeah, it sells at a high price, but it's very expensive to produce, I guess we can see from here. And so I guess, yeah, not double, but, maybe 80% more than the XR7 model when you look at it in costs. And why isn't the company using a constant, addition on top of the cost? Well, because the cost is something that you determine internally, but the selling price oftentimes is determined by market conditions. So if your competitors are selling products similar to yours, then you may be forced to accept the prices in the market. So if XR7 type models are selling around $100, you need to sell there as well. So these are like the perfect market, perfectly competitive markets. You're a price taker, not a price setter in this environment. So XR7s are selling for 100 and turbos are selling for 150. But the contribution margin of the XR7 is higher than that of the turbo model. So in this case, if you are compensating your salespeople based on the sales revenue, okay, then, and let's for the moment assume that it takes about the same amount of effort and time to sell an XR7 as it does to sell a turbo model. As a salesperson, what would my incentive be? Would I work on selling more of the XR7s or of the turbo models? If my compensation, if my commission is based as a percentage of sales value. Well, if I sell one XR7, and let's say I'm getting 5% of the sales price, I'd get $5. But if I sell the turbo, I get 5% of 150, which is $7.50. So I'm getting 50% more commissions when I sell this one. So I would focus my efforts on selling the turbo, which is not really benefiting the company. If I was selling the XR7, it's actually better for the company than selling the turbo model. So that is something to think about. Rather than base your sales commissions purely on the selling price, maybe you might also want to make sure that their contribution margins are either similar across the different products, or if they're not, maybe base your commissions on the contribution margins, or maybe use a mixture of sales price and contribution margin. That would probably lead to better results for the organization. So yes, to eliminate this type of conflict, commissions should probably not be based purely on the total sales revenue generated, but rather try to incorporate things which add value, more value from the point of view of the company, like the contribution margin. So another thing in a lot of companies up until now, we've kind of been assuming that we are producing and selling one product, one type of product, which is typically not what happens in real life. So in real life, you probably will be selling a number of different products, and the prices and the contribution margins, variable versus fixed expenses of these, are probably not going to be the same. So does this mean we can't use what we've learned up until now? Well, we can continue to use what we've learned up to this point under certain conditions. If we make certain assumptions, we can continue to use the models that we've constructed. And that assumption typically has to be that the relative proportion of your products is remaining about the same. So if you've been selling, for example, 75% of A and 25% of B, that proportion, if it remains consistent over time, then we can continue to use our formulas that we've seen up to this point. We will come back to the bicycle example. Let's take a look at another company which has two different products, and the do-all products and Superword. These are games. And in this case, if the company typically within its revenue or its sales mix sells 2 units of do-all for every 1 Superword that is sold, then if this ratio is consistent over time, then we can continue to use this in our calculations. And we can say things like, if our break-even point in units is a total of 30 units, and that is composed of 20 units of do-all versus 10 units of Superword. So that ratio of 2 to 1 needs to be consistent. And using these assumptions, we can still use a lot of the things that we have learned in our class. Otherwise, it becomes a little more complicated, but we can still benefit from what we've learned under any conditions. So back to the bicycle example. If the company that you have not only produces bicycles, as we've seen before, but the company also produces and sells carts. So these are carts used by children. So they kind of use the same materials. They have wheels, they have spokes, and so on. So the technology used is also kind of similar. However, the selling prices and a few other things are a little different. So if we look at what we've seen in the past, the bicycles had sales of around 250,000. This was 500 bicycles being sold. And the variable expenses were about 150,000. So there was a 60% variable expense ratio, which meant that the contribution margin was turning out to be 40%, or 100,000 divided by 250,000. 40% bicycles have a contribution margin. Whereas carts, for sales of 300,000, their variable expenses percentage is 45%, so it's 135,000, which leaves 165,000 for contribution margin. So the contribution margin ratio is 55%. So it looks like the profitability coming from carts is higher than the profitability of the bicycles. So notice that contribution margin for bicycles, 40%, contribution margin ratio, and the contribution margin ratio for carts is 55%. If this ratio of 250,000 to 300,000 is consistent over time, in that case, we may make the assumption that this sales mix is going to remain fixed. So about 45% of your sales are going to come from bicycles, 55% are going to come from carts. Then we can kind of use the combined numbers to forecast the future. So adding these up, total sales 550,000, made up of bicycles and carts. Total variable expenses 285,000. So this 51.8% variable expense ratio. Notice that it's actually in between the 60% and the 45% we have for bicycles and carts. It's actually a weighted average of those two. 55% weighted to carts, 40% weighted to bicycles, which means that the contribution margin is also weighted. So 265,000 over 550,000 gives us a contribution margin ratio of 48.2%. So that's what we will be using in our analyses to determine the break-even point and later to calculate any potential profits and so on. So if the fixed expenses for this company, which produces bikes and carts, is 170,000, then that would mean that under these sales conditions, we would have a net operating income of 95,000. Okay, so that's where we are. And again, the contribution margin for the company overall is 48.2%, and 55% of sales coming from carts, 45 coming from bicycles is where we are. So if we want to use this data. First of all, what would the break-even point be for this company? Can we still calculate one? Yes, as long as we assume that this ratio, 55 to 45, is going to remain consistent, then we can use this 48.2 contribution margin together with the fixed costs of 170,000 to calculate the break-even point. And again, the break-even point, you can calculate it in a sales number, dollars, Turkish liras, or in a how many units, excuse me, to sell. So in dollars, it is fixed expenses divided by the contribution margin ratio. So 170,000 divided by 48.2 gives us a sales, break-even sales number of 352,697. That is our break-even. And if you want to look at the fancy numbers in the spreadsheet, yes. So the 352,697 divided 45% between these two gives us these numbers. So sales number for bicycles. Well, notice that it is not an exact number of bicycles sold times $500 selling price, because unfortunately we don't always have the luxury of living in a world where the calculations end up with, exact number of bicycles being whole numbers. So in this case, this probably isn't a real place, because we'd have to sell, 0.3 of a bicycle and 0.4 of a cart to be able to end up here. But approximately, this is where it would be. And if your variable expenses are 60%, 45%, your contribution margins are this and this. So at the end of the day, this is where we are. Total of 352,697 sales, your variable expenses, leaving 170, 176 for your contribution margin. Well, why was it not exactly 170,000? Because we had calculated the break-even point to be 170,000. Why is it not? Well, because rounding error. We stopped using, the percentage actually had continued, but we, just used one decimal point. And as a result, there's some rounding error. But, for $352,000 of sales, $176 rounding error isn't that big of a number. So yes, we're still in the vicinity of, having break-even points. So if we review our rules that we have learned, okay, so if you have a sales mix, so if you have more than one product, we saw how to do it with 2 products. Can we do it with more than 2 products? Yes, you can. The only thing you have to check is you have to calculate the percentage coming from each separate product line. And if you can assume that the percentages of the product lines are going to stay the same, then you can use the same approach to calculate break even and other things for your company. So if you have A, B, C, 3 products, where A, B, and C are the percentage of the sales, then the contribution margin for the company becomes a weighted average of each of the contribution margins. So the break even for the company becomes fixed cost divided by the company's overall CMR, which is the weighted according to the sales revenues. To find out how many units must be sold at break even or for target income, find break even in multiple products. And then from that product, determine how many does this make of each separate product itself. So you can use that on your own. So again, reviewing the assumptions that we make when conducting a cost volume profit analysis. So we are assuming a few things. Selling price is constant. Okay, so because sales revenue is going to be price times quantity. So the price is constant. We're not changing it depending on how many we've sold, who you are. 2, costs are linear. So fixed costs are linear at that fixed cost, whatever it is, and variable costs are fixed per unit, which means that they are increasing at a steady pace as the quantity produced and sold are going up. If you have more than one product in your sales mix, then the mix, their percentages are constant. And one other thing, in manufacturing companies, inventories do not change. So units produced are equal to units sold. Why is this important? Well, because if your inventory levels were going up or down, well, then, for example, you could be producing more than you're selling. And as a result, even though it ends up in your inventory, your ending inventory, because unsold goods end up being added to your ending inventory, you would still have to pay for them. So we wouldn't be using the same quantity for calculating sales revenue, P times Q, and variable costs, which is this time variable cost percentage times Q, because the two Qs would be different. So as long as the beginning inventory and ending inventory are not changing, that means that everything you're producing, you are able to sell this period. So the analysis is able to function. Now, in real life, typically we have the problem that not everything can be directly tied to a single cost driver, like quantity produced. Sometimes you might have other things like what? Well, some things like raw materials might be tied to the number produced directly. But for example, shipping might depend on how many trucks you need to send. And sometimes, or how many orders are placed. And in one order, sometimes you might have just one thing being ordered, sometimes 100 being ordered. And from that point of view, each order might cost the same to process. But again, the amount included are different. So this might be something separate, which you need to utilize in determining how much your costs are going up or down by. So for the software company, for example, their variable costs, one, $40 per software package sold. But in addition to this, $15 per invoice issued. And sometimes in some invoices, you might have more than one software being sold. So the variable cost is kind of being driven by two separate things. So your operating income is going to be your sales revenue, which is P times Q, right? Selling price times the quantity produced and sold, minus $40 times the number of packages sold. But there's also $15 times the number of invoices issued. And as a result, and then finally, you also need to deduct your fixed costs for this to be your operating income. So revenue and fixed costs, we can leave those aside. But this part, 40 times the packages and 15 times the invoices, in order for this to be equal to zero, which is the definition of break-even point, sometimes, you might be able to find a few different points, combinations of number of packages sold and invoices issued, which yield you that zero profit point. So that is a problem. So in cases where there are multiple cost drivers, there can be potentially multiple break-even points. So you need to be a little extra careful in examining those cases. So here we have a comparison of basically the same company, but the information, the financial information, is presented in two different ways. On the right here, what we have is what it would look like in your income statement. So revenues minus cost of goods sold is your gross profit, minus your operating expenses is your operating profit, right? Whereas the contribution margin format, which we have been advocating is more useful for decision making, would look like this. Same revenues, $200, and your variable costs are made up of the same 125 and 62, but of the cost of goods sold, 120 are variable, 5 are actually fixed costs. So this is potentially the depreciation of the machinery and so on that you're using, which is determined, a fixed amount per year. And then similarly, the other variable and other fixed also getting thrown in here. So what we end up with is variable cost 120 from cost of goods sold, and then from 43 from other variables. Your total variable costs are 163. So the contribution margin is $37. And your fixed costs, total of 5 plus 19, 24, leaves operating income of 13. So again, the exact same information, but in one case, cost of goods sold and operating costs are how the expenses are organized. Whereas here, they're organized depending on their behavior. Are they fixed versus variable? And sometimes within cost of goods sold, you might have some things which are fixed. And sometimes within operating costs, you might have some things which are variable, which need to be moved around to do the correct calculations. And then let us finish up with a few example questions. And I will not give you the full lengthy solutions to this, but I will give you some of the numbers and the general way that you need to solve them. So please use these examples to make sure you're able to use the information that has been provided to you to solve some managerial problems. So if you have a movie theater and the fixed costs of this theater are $48,000 per month, and the tickets are selling for about $8 each. The variable cost per ticket, let's say that it's $2, which means that the contribution margin is $6, right? 8 minus 2. So what would the break-even point be? And give me this number in units and in revenue. Okay. So if we're using the equation, then you can do the calculation like this. The break-even in units is equal to the fixed cost, 48,000, divided by the contribution margin per unit of $6. That gives me break-even point in units being, if you sell 8,000 tickets, you will have exactly 0 profit or loss. If you wanted the break-even point in revenue, in dollars, in that case, what you do is, again, you start with the fixed costs, but you divide this by the contribution margin ratio. What was the difference? Well, the ratio is expressing it as a percentage. So $6 was contribution margin per unit. Divide that by the selling price of 8, by the actual price. So 6 over 8, or 75%, would be the contribution margin, the break-even point in revenues. 75% is the contribution margin ratio. So dividing 48,000 by 0.75 would give you the break-even point in revenues. So you can calculate this in 2 ways, actually. One of them is take 8,000 tickets, multiply by the selling price, or take 48,000 divided by the contribution margin ratio. Both of them should give you the same number. If you want to do this graphically, then here's the graph. And here, 48 minus 48,000 this is your fixed expenses. And then you start selling until you hit the break-even point at 8,000 tickets. Okay. After you sell 8,000 tickets, up to this point, you had been losing money. So the distance from here to here is how much your losses were. At this point, it's 0. And beyond this point, you are making a profit. Your revenues exceed your expenses beyond this point. So that's where we want to be. So this is per month. And what if we the same cinema that we have, movie theater, its capacity per month is 12,000, okay? 12,000 tickets. And that the movie theater has operated at 60% capacity during December. So of this 12,000, up to this point, we have been able to sell 60% of our regular allotment. So if you multiply 12,000 by 60, you should be getting 7,200. So you have sold 7,200 tickets up to this point. It's now December 30, and you can think of it as the end of the day, December 30. So there's only one day left, December 31st. At this point, have you made a profit or a loss? Well, what was the break-even point? It was 8,000. We have sold how many tickets? 7,200. So we're losing money. That's where we are. That's where we are currently. And here you can kind of do one thing. How much money are we exactly losing? December 30, one more day to go. So if we continue to sell at that same speed as we've been selling in this month, so 7,200 tickets divided by 30 days up to this point, it gives me 240 tickets. So we should still be able to sell another 240 tickets tomorrow under normal conditions. Okay, so the final loss is going to be, you know, a little less than the current price. So depending on how you see it, that's 60%. Is it up to this point we have sold 60% of 12,000, or if we continue like this, we will hit 60%, 7,200 tomorrow. So that's the difference. If they could capture 1,000 customers by lowering the ticket price to $7 for New Year's Eve. So we're not lowering the price for all days. We're just saying, hey, it's a New Year's special. And if you want to come watch a movie New Year's Eve, come on in. We're lowering it by $1. So let's try to attract more people. And if this works and we're able to attract 1,000 customers, but be careful, these 1,000 customers are only going to be paying $7 each. So these 1,000 customers, their contribution margin initially was $8 minus 2, $6. For these 1,000 people, their contribution margin is only going to be $5, 7 minus 2 variable cost. Again, $5. So using this information, what can we do? Well, if we had been selling 7,200 tickets, at that point, we're actually losing $4,800. So in the last day, by getting these additional customers at a price of $7 each, at a contribution margin of $5, then $5 times 1,000 customers means that our net operating income is going to go up by 5,000, which means that we will just turn a profit thanks to these additional customers that have been brought in. So should they do it? Yeah, if, you know, because on a normal day, we argued we get about 200, 240 new customers. This lower price on New Year's, together with the fact it's New Year's, if it gets us 1,000, then those additional customers end up pushing us just over into profitability for the month of December. Next, Doral Company manufactures and sells pens. They sell about 5,000 pens per year at a selling price of 50 cents per unit. Fixed costs are 900,000 per year and variable costs are 30 cents per unit. What is the current yearly operating income? Okay, so in order to calculate operating income, we actually have to do a few calculations. And you can take a shortcut to calculate operating income, you can calculate the contribution margin and then multiply the number of pens being sold by that to give you the contribution margin directly, and then from that deduct the fixed costs. Or you can choose to calculate, sales revenue, then the variable cost, take the difference, contribution margin, deduct fixed costs, and end up with the net operating income. But both of them will work. So let's do it both ways. If you sell 5 million pens at a price of 50 cents per unit, that means that your sales are going to be 2.5 million. Your variable cost is going to be 5 million times 30 cents, which is 1.5 million. So 2.5 minus 1.5 million means that your contribution margin is going to be $1 million. And if your fixed costs are 900,000 per year, that means that 1 million minus 900,000, your net operating income for this company is going to be $100,000 this year. That's where we are. What would the shortcut have been? Well, 50 cents minus 30 cents, 20 cents is your contribution margin per unit. Multiply that 20 cents by 5 million would have directly given you the 1 million contribution margin. And then deducting 900,000 would tell you that you are making an operating income of $100,000. For this company, what is the current break-even point in sales dollars? Okay, so again, when you're calculating the break-even point in dollars, what you need to do is take the fixed costs, 900,000, divide them by the contribution margin ratio. The contribution margin ratio is equal to contribution margin divided by selling price. So 20 cents is the contribution margin per unit divided by the selling price per unit, 50 cents. So 40% is the contribution margin ratio. So 900,000 divided by 40% gives us a break-even point in sales revenue of $2.25 million. $2,250,000 is the break-even point in dollars. And then we have some other changes to the question. Well, what would the new operating income be if the variable costs go up by 4 cents? Well, 30 cents before, they go up by 4 cents, which means that the contribution margin, which used to be 20 cents, is now only going to be 16 cents. And as a result, if the contribution margin becomes 16 cents, multiply that by 5 million. So 5 million times 0.16 is equal to 800,000. That's the contribution margin. And at that level, if your fixed costs are still equal to 900,000, your operating income will be minus $100,000. 2, a 20% decrease in fixed costs, a 20% decrease in selling price, a 10% decrease in variable costs, and a 40% increase in units sold. All of this happening at the same time. So go over them one by one to make sure you understand what each of these is becoming. So 20% decrease in fixed costs means that fixed costs are going from 900,000 down to 720,000. A 20% decrease in selling price means that what you were selling before for 50 cents, now you're selling for just 40 cents. 10% decrease in variable costs, so which means that your variable cost used to be 30 cents. Now they are 27 cents per unit. And a 40% increase in units sold, which means that you used to be selling 5 million pens in 1 year. You're now selling 7 million pens in 1 year. And if you want to calculate the operating income under these new assumptions, these new conditions, well, what you need to do is first calculate the contribution margin. Contribution margin, 7 million pence, new amount, new quantity, multiplied by 0.13. 0.13 is the new contribution margin per unit, because selling price went down 20% to 40 cents, and the variable cost went from 30 to 27 cents. So now 40 minus 27, 13 cents is the new contribution margin. So 7 million times 13 cents gives you 910,000. That is your contribution margin for the company. And your variable cost went down from 900 to 720,000. So 910 minus 720 means that your net operating income would be 190,000. So yeah, all of this can still be done relatively quickly, relatively easy with a calculator to understand the effect of all of these changes. Compute the new break-even point in units for each of the following changes. What if fixed costs go up 10%? Okay, so this is from the original point. So if fixed cost goes up 10%, it's going from 900,000 to 990,000. So break-even point in units is going to be calculated as fixed cost divided by contribution margin per unit. So 990,000 divided by 0.20 by the original selling price minus variable cost. 50 minus 30 is equal to 20 cents. So it would become, the break-even point in units is 4,950,000 pence. 10% increase in selling price, so from 50 to 55 cents. And 20,000 increase in fixed costs. So fixed costs go from 900 to 920,000. The break-even point in units becomes 920,000 divided by 0.25. So the new break-even point in units is going to be 3,680,000 pence sold. And example 3. 2 restaurants that are open 24 hours a day. Fixed costs for the 2 restaurants together, 450,000. Service varies from a cup of coffee to full meals. So many different types of individuals walk in. Average sales check for each customer is $8. The average cost of food and other variable costs for each customer is 3.20. Okay, so using this information and plus the income tax rate is 30%, target net income is 105. So using all of this information, what are we going to calculate? First of all, if your target net income is 105, this is after tax. So if the tax rate is 30%, first thing we need to do is first go from the bottom, from your target net income. Tell me what is the target net operating income that you need to generate in order to have this 105,000 of net income. Well, 30% tax rate. So 105,000 must be equal to 0.7 of the net operating income. So dividing 105,000 by 0.70, that helps us calculate that the pre-tax net income must have been 150,000. So now that we have 150,000 target net operating income, if we also know that our fixed costs are 450,000, to calculate the how much sales we need to take the 150,000, the net target net operating income, plus 450,000. So that comes up to 600,000. That is the contribution margin that we must have to be able to obtain this level of sales. So in order to have contribution margin of 600,000, what do we need to do? So let's go to the next page. Compute the total dollar sales needed to obtain the target net income. Okay, so we showed that for that target net income, we need 150,000 target net operating income, and to have a net operating income of 150,000, we must have, add 450 to that, we must have 600,000 of contribution margin. So to have a contribution margin of 600,000 with a selling price of $8 and a contribution and a variable cost of $3.2. So $8 and $3.2. The difference between these is 4.8. So that is your contribution margin per check. So coming back to this, if we want to have 600,000 contribution margin, 600,000 divided by the contribution margin ratio. So that 4.8 divided by $8 is the contribution margin ratio, 0.60. So 600,000 divided by 0.60, the contribution margin ratio, gives us 1 million in sales. So that's how much dollar sales we need to have to be able to end up with exactly 105,000 net income for this company. How many sales checks are needed to break even? Well, break even, for break even, we need to do the calculation a little differently, right? What do we need? Well, in that case, we just need to have a net operating income equal to 450,000. So to calculate that, you would simply take 450,000 and divide that by, but it won't say how many sales checks are needed to break even. So yes, in this case, 450,000 divided by 4.8, the contribution margin per unit, okay? So $4.8 per check. In that case, you can do that calculation and you would end up with the break-even sales in checks, in units. Compute net income if the number of sales checks is 150,000. Okay, so for 150,000 sales checks, multiply that by the contribution margin per unit of $4.8. That gives you a total contribution margin of 720,000. Fixed costs were 450,000. So deduct that, and you should end up with net income of $270,000 if you're able to have 150,000 customers come in to your two stores. Again, all of this is assuming that the sales in the two restaurants are similar in types of how many people order just coffee, how many people order the other food, so that on average they all look kind of similar across the stores, and these ratios are staying relatively constant. Multi-product example. So in this case, what do we have? We have a company which has two models of the thing it's trying to produce and sell. There's a regular and a deluxe model. The deluxe model costs more and less of them are being sold. So it's probably a nicer, more fancy version of it. And a total of 600 units per year are being sold at a price of 500 for the regular and 750 for the deluxe. So the sales volume, 200,000 regular, 150,000 deluxe, for a total sales volume of 350,000. And okay, the variable expenses for regulars are 120, for the deluxe they're 60, and these are the contribution margins of each. Combining these together, we end up with these numbers, and the contribution margin ratio becomes 48.6%. Now, fixed expenses of the company are 130,000, which means that under these assumptions, you would have a profit of 40,000. But now we're being asked, what is the break-even point? Well, the break-even point for that, I need first, if I can assume that the regular and deluxe percentages are going to remain the same, and basically take the ratios of 200 over 350 and 150 over 350. So the percentage of regular to deluxe revenue being generated, if they stay constant at about, well, what is it, just over 57% regular, around 43% deluxe model being sold, generating sales revenue because they have different prices. If that remains constant, then basically take, what is it? I need to take the 130,000, the fixed expenses, divide that by 48.6, the contribution margin percentage. And that gives me 267,489.71. So that is the break-even point sales amount that you would need to have to be able to earn just enough to meet your fixed expenses, leaving zero net income. How much sales revenue of each product must be generated to earn a before tax profit of 50,000? So for this to be equal to 50,000, how much must the contribution margin and everything above become? Well, again, what do you do? It's just like I need 50,000 plus the fixed expenses. So 180,000. So 180,000 divided by 0.486. If you do that calculation, it gives you $370,370. So that is how much sales revenue you would have to generate, assuming, again, the percentage of these are remaining constant. That's how much total sales you would have to generate. And then that 370,000 can be divided among the regular and deluxe models into 57%, 57.14% actually, going to regular, which is 211,640. And 42.86% going to the deluxe model, which is $158,730 of deluxe model sales. So that's where we ended up. And on the last slide, we have a final example, but I'm going to leave that up to you. I hope you can do this on your own. I'll also try to send you some additional questions for you to take a look at. That's been the last part of what I want to talk about in managerial accounting. Thank you for listening.